So sometimes we have decimals that repeat numbers. So these are non-terminating, meaning that they will never end. The part that repeats will just keep repeating and repeating and repeating forever. So some examples are 2/3. 2 divided by 3 gives us 0.666666, and it would never end. So in order to save writing all those sixes, we use a bar over the pattern part, whatever that is repeating. In this case, the part that is repeating is just a 6, so we only need 1 6 with a bar to show that this is really the same as 6 repeating forever and non-terminating. So 0.16, now the bar is over the 1 and the 6. So that means 1 6 is the repeating pattern. So it would be 0.161616 on and on and on and on. 0.16, where the bar is only on the 6, that means this one happens before the pattern starts, before the repetition begins. So it's 0.1, then 6 has the bar on top of it, so it's 6 that repeats forever. 0.2375 with the bar above the 7 and the 5. 2-3 happens before our pattern, and then 7-5 is what repeats. 7-5, 7-5, 7-5, on and on and on. 0.723, where the bar is over top of all the 7, 2, and the 3. That means that's the repeating piece or chunk. 723, 723, 723, etc. So how we round? 0.6 would be approximately 0.667, because if we go to the thousandths where that 6 is and we look after it, it's another 6, which is greater than 5. So that tells us take this 6 here and round it to a 7, 0.667. And of course that's rounding to the nearest thousandths. 0.6 equals approximately 0.67, rounded to the hundredth, because that means we're going to back up what we're looking for by 1. So here's the place we're interested in. After it is still a 6, because everything is a 6, greater than 5, take that 6 and bump it up by 1 to a 7. Or 0.6 repeating is 0.7 rounded to the nearest tenth. 0.6 to the nearest whole would be 1, because we have a 0 in our whole part, but after it in the tenths is a 6. 6 is greater than 5, so that tells us to look at the 0 and increase it by 1.